say that I have a quadratic equation of the form x square plus bx plus c is equal to 0, and the roots of the quadratic equation, I know that they are alpha and beta. So when I say alpha as a root and beta as a root, all I mean is if I substitute alpha for x in the equation, that is if I write alpha squared plus b times alpha plus c, if I evaluate this, I'll get it as 0. So this is the meaning of alpha as a root, and equivalently we have also seen that x minus alpha would become a factor of this equation right here. So formally this was called the factor theorem, and this one was called remainder theorem. But without going into those theorems, for now let us just assume that x minus alpha and x minus beta also, because the beta is also root, so x minus beta is also a factor of this given quadratic equation. So in this video we would like to establish the relationship between alpha and beta and b and c. That is the relationship between the roots of an equation and the coefficients of that equation. And we are dealing with quadratics now. So maybe I can write the same equation in some other form that involves these alpha and beta, and then maybe I could do something with that new equation. I could maybe match the coefficients and do something. So let us just see. So to write it in the form of alpha and beta, I know that x minus alpha is a factor and x minus beta is a factor, and if we multiply out these factors, we'll get back the same equation, because we'll get the x squared term and then we'll get some other terms. So I know that I'll be getting back the same equation, so I'll say that this is equal to 0 because it's the same equation after all. So maybe if I simplify this, this will be x squared minus beta x minus alpha x minus alpha minus beta, which is plus alpha beta or plus beta alpha, which is equal to x square minus alpha plus beta times x plus alpha beta. So see, we are getting the one other form of the same equation. So now we can compare the coefficients, because it's the same equation after all. So we'll compare the coefficients between these two equations. So what do we get? We get that I'll choose a green color now, or maybe I'll choose a white neutral color. I get that minus alpha plus beta is equal to b, because that's the coefficient of the x term, and then the x square term has just one coefficient, so we need not write it, and the constant term c becomes equal to alpha beta from the second equation. Well, what does this simplify to? This says that alpha plus beta is equal to minus b, and well, this remains the same. Alpha beta is equal to c. So we have established a relation between the roots of an equation alpha and beta and the middle term and the coefficient of the middle term and the last term minus b and c. So sum of roots is equal to the negative of the middle term, that is minus b, and product of roots is equal to c, that is the constant term of the quadratic. And we mind you that we have looked at quadratics only of the form x squared plus bx plus c, where x squared had a coefficient of 1. So in our next video we'll see the relationship between roots and the coefficients of the quadratic equations of a general form, that is ax squared plus bx plus c is equal to 0. So what will the relation be? What can we learn from all this? So we'll look at this in the next video. Thank you.